Hello and welcome to this demonstration of the eCore metamodel importer. Basically, this importer begins with an eCore file which contains a bunch of classes and interfaces and enumerations, and classes can have attributes with types, and types can be either EMF compliant types like these two that begin with the E, or it can be types of classes, and it can be types of the types can be classes or enumerations that are already there as part of the eCore file. And basically it can have interfaces, and it can have basically classes can implement multiple interfaces, or they can inherit multiple classes, and they can also have references to other classes. So this is how the basic structure of an eCore file looks like, and the importer basically maps all of this in as concepts, as interface concepts, and the other basic concept declarations as part of the structure of a language element of an MPS. So let's look at the importer itself. The importer is basically placed as part of the EmbedR's MPS util. It's there in the EmbedR master now, and basically it's in a folder called eCore transformation utils, which is part of the REST folder. And basically the thing that is of interest to us is the metamodel importer right now. And the metamodel importer as such has three folders and one language. The folders are basically, one is the runtime where the actual transformation happens. Then there is a testing runtime. There is a bunch of test languages with which we test against. But for this demonstration, let's look at the sandbox, which is where we'll test the importer itself. So as I said, if you right click on the generator or something, you're not going to have a look at the import eCore utils option, but only if you go to a structure, you're going to have the import eCore file option. And let me choose this eCore file here, which basically tries to demonstrate all of the different kinds of challenges that are there and how we tackle them. So let me go to the sorry. Yeah. So if you notice, the importer as such, for the test class 1, it has implemented test interface 1 and test interface 2. But for superclasses, since it can't, my MPS does not support multiple inheritance, from the second and third superclasses, basically super interface is created, which has the same properties as a superclass, and basically this test class implements them as interfaces. And for types, the challenge here is that these attributes, the attribute attr1 is of type int, which has a primitive, which has an equivalent primitive data type in MPS. So of course it's easy to solve. But the problem with the other attribute 2 is it's of a type invocation target exception, which has no equivalent in the MPS world in the primitive data types. So the way we've solved it currently is we've added an annotation called EMF data type, which basically points to the type in EMF that MPS doesn't understand. And the other thing is that, let's say if there is an attribute which if there is an attribute which belongs to a type of an enumeration that is already there, of course the reference is made, and so yeah, and this is how it handles it. And in the enumeration, there is a challenge that we need to tackle. For example, okay, so this enumeration does not have that problem, but let's say EMF also allows you to write enumerations and give values as just, it allows you to give non-unique internal values. So this can be both 0 and 0 here, which is the case with certain packages. And in that case, what we do is that we kind of generate those values ourselves. I'll show you an example of that now. And also, of course, references are as part of references, and also the cardinality is handled here. So EMF basically gets the cardinality of the reference from this lower bound and upper bound. Here the lower bound is 0 and the upper bound is 1, and based on that we've also given the cardinality of the references here. So the next challenge here would be to look at some more real models and see what are the kind of challenges that are there. So let's look at this Franka model. In the Franka model, there is like a lot of classes, and I'll also show the transformation also scales kind of. And so basically, if you look at it here, there is something that EMF allows you to do, which MPS will not allow you to do. Basically, there is no constraint check to see if a non-abstract class or an abstract class here, F-typed element, can inherit a non-abstract class, which is, when it comes to object-oriented concepts, this shouldn't be allowed, and MPS has constraints for it, but EMF doesn't. The way we handle it is that we kind of throw an error message pointing to the right direction and move on with the other classes. So yeah, let's look at it here. Yeah. So yeah, as you saw, there was an error message which said that that particular class could not be imported because it is an abstract class that was inheriting a non-abstract class. Let's look at one more example of this EMF challenge that I'm talking about. So that would be the Amalthea here, and in Amalthea, for example, all of the enumerations have basically non-unique internal values, which is also not permitted in MPS. So the way we handle it is just remember this thing time unit here, and so if I import the Amalthea, takes a couple of seconds, that's okay. Let's look at time unit, which is our interest here. An enumeration called time unit. Yeah, so basically in MPS, we have our transformation tool kind of generates unique values for this case. So basically that's how we've handled it.